Okay, and if you are ready, we just move to next section is about introduction to NumPy. And NumPy just provide efficient and convenient arrays for storage and manipulations of large data set. Maybe so many people will think if today we wanna deal with the data set, and maybe we can use a Python's array, and we can use array to organize the most of data. But sometimes the data set is too large. So we need to use an efficient way is NumPy. Okay, if today we use NumPy, this can help with deal with the large data set. And NumPy is just a Python for data analyze. Okay, so we will call this as numericals Python. So if today you wanna deal with a number issue, and maybe you needed to install the NumPy package, we needed to import the NumPy package. Why I say that is just import NumPy, not install NumPy, because NumPy already be installed in your Anaconda. Our Anaconda is strong enough, so they already help you to install the NumPy in your computer. And actually, NumPy is a library in Python programming language for data analysis and or machine learning. So maybe if today you wanna enter into the artificial intelligence domain, and sometimes we wanna deal with machine learning or deep learning, and you needed to deal with a large data set. How to deal with this large data set? Use NumPy, and it supports a multi-dimensional array. Why they need to emphasize the multi-dimensional array? The traditional array, we call that as one-dimensional array. And here they suppose a multi-dimensional array. Maybe that is 1D, 2D, 3D. If today the data is about 3D, this is too complex. Okay, so we needed to use NumPy. Okay, so multi-dimensional array library, we also call this as this one. And NumPy using an array is instead of a list. So that is a multi-dimensional array, just like this one. If that is a 1D array, and we can see that is just a one line. And if today that is a 2D array, maybe we have the X and Y. So here is a shape 2 and 3, and a 2 and 3 we can see maybe there has a two line and 3 columns. So we will say that is a 2D array, and later that is about 3D array. Okay, so if this data is about 3D array, that will make your that is really test your data and analyze capability. Okay, so if we wanna use a 3D, I think that is waste so many memory in your computer. If you use a traditional array, you need to spend so many memory. But if today you use NumPy, this can help you with a quick way, an efficient way. So we wanna introduce how to use NumPy in here. So why do you use NumPy over list? You use NumPy but not use list, because list is just a basic part. But now if you wanna enter into advanced step, you need to learn NumPy. And the most important thing is about the speed. If today you use the list, maybe that is just like a chain, it's so slow. But if today you use a NumPy, that is just like you take a Taiwan high-speed rail, that is really fast. So if you wanna enjoy the speed and to deal with a large data set, you need to learn the NumPy. Also, we can also go to the Stack Overflow to ask why we need to use NumPy and what's the advantage of NumPy over the regular Python list. And in here you can see this one. The NumPy arrays are more complex than Python list. Okay, if today we use maybe Python, that will take at least 20 megabytes. And if today I use a NumPy 3D array, with a single precision float in the cells would fit in 4 megabytes. So maybe that is 5 times bigger than our NumPy. Okay, so I think the NumPy is really quick. Okay, but that is only the 20 megabytes and the 4 megabytes. But if today that is about the gigabyte, can you imagine that? That is totally different. So most of people, they really recommend to use NumPy. But I think in your project, maybe you will not need to use NumPy. But I still need to teach that, because I think that play a critical part in your following career. Maybe some people, you wanna go to the financial section, or you wanna go to the other data department, you also need to use NumPy. Okay? And I think the most important things why they can with a quick speed is because the data types in NumPy there can separate in several things. Okay, for example, traditionally we only have a term is about float, but in NumPy we divide the float into 3 parts. It's about floating 16, floating 32, floating 64. Okay, so if floating 16, that is a half precision float, single bit. Okay, 5 bit exponent, and the floating 32 is a single precision. And if today we use a float 64, that is double precision. We can see if today we use a float 64, that means our float number will become more precision, but also with too many memory. Sometimes we don't need to use 2 positions data type. Maybe we just use the half position is enough. Okay, so you can decide today you wanna use floating 16 or float 64. This is depends on yourself. And also the on-site integer. Okay, that can divide into 5 types, and the integer can divide into 3 types. Okay, so this is really depends on you. You can decide by yourself what's the data type you need to use. Okay, so we needed to learn what is NP array, and actually NP array is a function that creates a new NumPy array that is different from the traditional array. So we can start to practice that about this one, about NumPy. The first thing is we need to import NumPy as NP. Import NumPy as NP. Actually, that is not needed to call it as an NP. You can also use NYUP or the other thing. You can use the other name, but that is just my habit. So I call NumPy as NP in here. So I import NumPy as NP in here. And later I needed to set up an NP array is 20, 18, 37, and 28. And you needed to set up by yourself. Maybe you can use a different number with me. And after that, I call A in here and shift enter. So I can see this one. Okay, I just print A. So you can start to try to this one. And if you already go to this step, we needed to move on. You can see here has so many things, so many functions from our NumPy, and maybe we can know what about this array. We needed to gain an overview from this NumPy array. Okay, so we can understand their size, their shape, their NDIM, their D type. We can know all these things. So I just enter it. So if today I just wanna print this new array, it's just like this one, just like our traditional array. We can gain any points. But if today we can get you wanna get the size, just the total number of the elements in this array, we can understand, oh, here has a 4 elements in this array. Here is a 4 elements in this array. And then later, this is for an n by n matrix. It's just about they wanna give you a shape. Maybe this is 2 by 3 or 3 by 4, but actually this is just 1 by 4. So they only show the 4 in here. This is their shape. Okay. And the NDIM is about number of the dimension of an array. So we can see here only one dimensional array. So here is 1. This is just NDIM, one number of dimension. And the later one is D type. D type is the data type of the element. And actually, you know the integer can divide into integer 32, integer 16, or 1464. This can divide so many sub data type. So we needed to understand what's their truly their data type. So I needed to use a D type to get what's the data type. So that is integer 32. I just shift enter, so you can see this one. And I give you many 1 or 2 minutes, and you can try to practice about this. Okay, and now we just move on. We already understand what is one-dimensional array and what is two-dimensional array, and here is three-dimensional array. Three-dimensional array, and you needed to use this way. You needed to use this way. In here is 1 dimension, and here is 2 dimension, and here is our 3 dimension. Okay, so that I will call this as 3 dimension. And we only have the comma between 2 objects. If this object is a less one, we don't need to put comma in here. Okay, so you can see these 2 objects, and we needed to set up a comma in here. Here has 2 objects, and we have a comma in here. Okay, so here is our 3-dimensional array. So I can operate it. You can see this one. And now you can create the 3-dimensional array by yourself. I think in these these following 3 lectures, we will focus on how to apply this function. Okay, before our midterm exam, we needed to understand all the things. But now I think the major part for you is you needed to understand, oh, this function can apply in which part of my project. Okay, so you try to understand the power of the function. Okay. And if you already created your 3-dimensional array, and we can move on, and we can try to test the NP empty. I needed to give the 3 dimensions. So 3 dimensions means we needed to put 3 values in here. Okay, we needed to put 3 values in here. So the beginning empty will become this one, and I run it again. So every time will just become the different number. Okay. Different number. And if today I use NP zeros and 2, 3, 4, okay, and you will see what is 2. 2 is means we have the two objects in here. So that is 2. Okay, what is 3? In each one we have a 3 line. In each one we have a 3 line. Here we also have a 3 lines. Okay, and in each line we have a 4 number, 1 2 3 4, 1 2 3 4. So this means is 2 3 4. Okay, so if today I want to create NP1s with 2 3 4, or you want to create 4 3 2, we can run this again. Do you think this will different from this one? 4 3 2. Is the shape will become the different? We can run this. You can find out that 4 is mean 1 2 3 4. And what is 3? In each one we have the 3 lines, 1 2 3. And in each line we have the 2 number, 1 2 1 2. Okay, so that is 4 3 2. Okay, so you can try to use a different number and to use a NP0, NP1s, and with 1 dimension, 2 dimension, 3 dimension. Okay, I think all the things is sometimes if I need to learn all this function, I will try to see the description at the beginning, and maybe I will spend 30 seconds or 1 minute to read the function, what's the power of this function. And after that, I will try to test it. I needed to code it. Okay. And when I code it, I will use a different number to compare the different results. And I will understand what's the meaning of all these programming. Okay. So I think that is the approach I learned the Python. Okay, and if you already get this part, and we need to move on this one. Do you remember what is NP arrange? NP arrange? We use NP arrange like in the past, right? Maybe we just NP arrange 10. I can show you. Print NP arrange 10 in here. You can see this is from 0 1 2 3 4 5 6 8 9. But if today I wanna put 3 numbers in my NP arrange, what's the result? That will mean we will start from the first number. We will start from 0, and we will stop in 10, and each step is 3. Okay, so that's I will try to use. So what's the result? You can guess that. What's the result? Zero, 3, 6, 9. Okay, each step is 3, 3, 3. Okay, but we stop in 10. Okay, and if today I use 2, I set up each step is 2, and I can see 0, 2, 4, 6, 8, but before 10. Okay, so if today I start from 1, 1, 3, 5, 7, 9. Okay, so that is start, stop, step. And actually, only the first number we needed to use, and the second number and the third number, that is optional. So if today I use 1 and 10, I only use the 2 number in here. The result will become 1 2 3 4 5 6 7 8 9. Okay, they start before 10. So one is start and the other is stop, and we don't need to set up the step. Okay, so that is really depends on yourself. Today you wanna put 1 number in NP arrange, or you wanna put 2 number in NP arrange, or you wanna put 3 numbers in NP arrange. So that will just become the start, stop, step. Okay, so just run it and you can see this one. So here is the part about the NumPy. I think that is only the best part of the NumPy. NumPy still has so many things you can learn, but I only give you a little bit understand about the NumPy. Okay. So NumPy will stop in here.